Yeah, thanks for inviting me to give this lecture. I'm going to talk to you in the next 2 hours or so. I'll try to not bore you in the next 2 hours or so. I'll talk to you about gender and representation in academia. Ask me questions, stop me in the middle, ask me clarifying question, whatever you want. You can hear me, right? We're good, yeah? Good. And then we'll probably have some time at the end as well if you want to talk to me as well, one-on-one or ask more questions. Okay, so let's get into it, right? So I'm gonna talk to you about gender and representation in academia. And let me kind of start by giving you a big picture of what we're going to do. It's really undeniable, right, that in the last 60 years or so, the world has changed when it comes to gender. And in particular, women participation in the labor market has steadily increased. And that's really remarkable. It's a tremendous gain for us women, and it's good news, right? At least most people would see that as good news. Yeah? Despite this steady increase in labor force participation, there is unevenness in those gains, right? And this can be seen particularly in our world, the academic world, professors and researchers, among others. And we can see in that second picture the evolution of the number and share of female scientists from 45 to 2005, the same evolution, the same increase, right? And yet, we're clearly not at the 50% share, right? We're short of that. Here, we're roughly, at the 30%. Okay, so what am I going to do today? I'm going to zoom in this academic world, and I'll split the talk in 2 parts. I'll first talk to you about just basic facts, so we know and understand what are the gender gaps and the gender differences in academia. And then I'll dive deeper into my own research, in particular a very recent project where I'm looking at mentorship and gender gap in academia, meaning how a lack of mentorship, a lack of female professors at the senior level, could be a potential factor contributing to this gender gap. Good. So let's start with just getting a sense of the basic facts. For this part of the talk, I'll mostly show you results from the literature, and there'll be 2 papers I'm going to use in order to provide evidence for this gender gap. The first one is Huang and co-authors, a paper published in 2020, and the second one would be by a set of economists. I'll tell you that in 1 second, right? So going back into the first picture, there's been a steady increase of the share of women among researchers more generally. Yet there has been unevenness in that representation, and we can really see this when we compare math, physics, and computer science that have a share of 15% of scientists that are female, and then psychology, on the other hand, with a share that's roughly at 33%, right? Okay. If instead of looking at the set of all scientists publishing, we zoom in the top universities and look at their faculty members instead, meaning professors, assistant professors, etc., we find a picture that's very similar, right? Like, evolution, clearly more women in academia at top universities, and yet heterogeneity at the same time, right? So what we find again is that mathematics is going to be, on the lower end of it, physics is on the lower end of it, right? And then biology, in this case, will be on the higher end of it. Okay, good. Now, we can zoom in a bit more in economics, right? And we're gonna find something roughly similar as well, right? So this is like a figure taken from one of my projects with Camilo Garcia Jimeno, where we are showing the share of papers that have at least one female co-author, meaning the share of paper where one of the scientists that contributed to that paper was female, and the share of women publishing. And we see something very, very similar, right? There's been a steady increase, and yet we're clearly, very short of the 50%. Okay. Now, just for the sake of it, right, because France happened to be looking really great in this picture, there is heterogeneity across country. And here, in particular, we can see that most countries have evolved, right? The share has increased a bit everywhere, but France and Italy are going to be at the top of that evolution. And Japan is going to come out as an outlier, right? So the share of female Japanese in academia is actually strikingly low relative to the others. This division by regions, you see that in many other settings as well, right? So it happens that Europe somehow seems to be doing well when it comes to female representation. Here we're only talking about, share of women, scientists' share of women in academia. Okay, good. And then something else that comes out when we start dividing the data set a bit more is that the evolution, is slightly slower. The progress is just slower when we look at the full professors compared to the full body of, scientists or the full body of professors, right? So, and that's something we're going to find, generally across all these STEM sciences, but we're also finding if we zoom in economics, so here we have the plot for the economist, right, where the full professors, the share of full professors, although increasing, right, it's still clearly very low relative to starting at the PhD level. We have about 30% of the PhD students that are female, and then we lose a bit of them at the moment of becoming assistant professor, and then we lose a bit again at the moment of becoming associate professor, and then the lowest share is going to be at the level of the full professor, right? Good. And what comes on the other side of this picture is actually a pattern of gender gap in terms of career length, right? So when we look at the career length of the male and the female scientists, typically people have found that women have shorter career compared to men, and that seemed to be explaining part of the patterns in gender gap in productivity as well, meaning in the number of papers that they are going to produce and publish as well, right? Okay. Now that we've done the representation side of it, right, the other dimension we're interested in when we think about the gender gap is not only how many women do we have out there, but are these women producing the same number of papers or not, meaning gender gap in publication. And again, we're going to find a systematic picture of women, female scientists, female professors, publishing fewer papers relative to their male counterpart that we're going to call the gender gap in publication, right? So we see a difference in total productivity through their career. That difference is there, across all countries. The difference is again there across, most STEM field. And we're going to also find like a gap when we're looking at ranking, right? At this stage, I wouldn't read too much in this gap increasing because the baseline number of papers is also increasing, right? And hence, it could be that in percentage term, this gap remain very similar across the board, right? That's something that, we won't be able to tell from these pictures. Okay. And then we can systematically run regression models. I don't know if you're familiar with what a regression model is, but we can systematically run a regression model of the publication record of male and female and look at the difference between the two after controlling for a bunch of characteristics and find again, a gap through time as well, right? So this gender gap in production that we're seeing, at least like looking at the set of professors in top institutions, doesn't seem to have declined through time in this picture. Okay, good. Now, putting some of these things together, as I was suggesting earlier as well, right? There is this gender gap in career length. I've shown you a gender gap in total productivity. And one thing, that this paper, the Huang and co-author here have been suggesting, right, is that when we plot the gender gap in career length for each field against the gender gap in total productivity, there is a positive correlation between the two, suggesting that part of the reason women maybe publish fewer compared to men is also just a shorter career more generally. Good? Good. Okay. So, big picture we want to keep in mind here is there is a gap in representation. This gap is not the same across all fields. It's going to be stronger for more quant field. There is also a gap in production, right? Like women somehow seem to be producing fewer paper through their career relative to men, right? So now the big question becomes, how can we explain such gender gap in productivity, and how can we somehow, for the sake of representation and inclusion and diversity, have more women in the profession as well, right? Good. So there is a bunch of project papers out there in the literature trying to explain the gender gap, both in representation and in publication. And this paper have pointed at a number of factors, right? The main one people seem to be coming back over and over again are going to be issues of work-life imbalance, meaning somehow the work-life balance is not suited for women, and then maybe they push themselves out of the academic world You have issues of stereotypes as well that seems to be important, both in terms of I don't think I'm good enough in math, and hence I'm not going to study some things, right? But also, the population at large could, have some biases, unconscious biases that could hinder the development and the representation of women in science more generally. And then one of these factors that have received quite a lot of attention is simply related to maternity, right? That women somehow right after maternity end up having a maternity penalty, and they publish less, they move a bit out of their usual career, and maybe coming back is slightly harder, but for sure it seems that there seems to be a publication penalty that some papers have suggested that seems to be important. Okay, now next to all these factors, what I'm going to focus on in the rest of the talk is the factors that are more related to relationship, right? And by that I mean the fact that we live in a social environment, or work environment is a social environment, and we might have a difference in the way we relate to our senior professors. There might be a difference in the way we relate in, or either relate to our role model, the difference, right? But we might also not be able to find, mentors as easily, and all these things could plausibly, hinder and create obstacles down the line, right? What we are going to do here is think for the rest of this talk, more specifically, we're going to think about the absence of senior female professor as a factor hindering the growth of a junior professor, right? So the idea is that relationship, more generally, matters for career outcomes, right? If you end up at, your future job, the relationship you might have with your manager could matter at the moment, for instance, of getting a promotion, right? The same thing is going to happen in academia. We work with others, we referee each other's work, and somehow, all these small informal interaction, whether someone likes you or not, no matter if you want to admit it or not, is going to make, could plausibly make a difference in our career production and outcomes as well, a prospect of promotion, right? This has been shown within a big financial company by a recent paper. I clearly don't have the right year. This is 2023 and not 2003, where they've shown that within a big financial companies, they had area where people could have breaks and chat with each other, and somehow people who were mingling and chatting more with their manager also had a higher probability of getting promoted, right? So that's one example of how relationship can plausibly matter for promotion, but also for pure representation, of some group rather than others in a certain industry or occupation, right? In our environment, right, the academic one, there are tons of these relationships that matters, right? We have relationship with our co-authors, we work with others, we have a relationship with people at seminars as well, we go present our work and then talk about our work. We have relationship at the start of our PhD with our advisor, right? That's an important one that also seems to matter. And also simply with senior faculty members in our field, right? And each and every one of them somehow we can see mattering, right? Our ideas will come out of talking to people. The quality of our thesis will come out of our advisors giving us a recommendation on what to do or not. There will be a flow of human capital that will, there will be human capital formation that will come out of it. But, at the moment of writing a letter of recommendation or thinking about a potential job prospect, it's kind of good to have a tight connection with the senior members of our profession, because they might think of us when there is an opening, right? Okay. Now, relationship matters, but if in addition, we believe that relationships are gendered, right? Meaning not that all men get along with men and all women only get along with women, but somehow there is a distribution of type, and women are more likely maybe to get along with other women, and men are more likely to get along with other women. Then the simple absence of female professors at decision-making position could plausibly hinder both through the human capital formation channel or the pure career outcomes, meaning there is a position available there, I'll write you a letter, etc., right? We could see the absent senior female professor during the PhD program, hindering the early career of female graduates, right? And this is exactly what we're gonna do during this project. We're gonna provide you evidence that indeed, the absence of senior female professor has an impact on the early career of these female graduates. Okay, so, the big question is, how does the presence of female professors affect the early career outcomes of female PhD students in economics? Now, what's really nice about the PhD is that it's kind of a hybrid between a work environment and the education, right? And you can think of it as some form of apprenticeship, yeah? The main challenge answering this question is that places that have more female professor, students that end up in places that have more female professor might just fundamentally differ from places that have more male professors. So what we're going to do in this project is to try to explore the variation in the presence of female professors at different department, economic department, because we're going to zoom in economics, and we're going to use the variation that's induced by sabbatical leave. And I'll tell you in 1 second, a tiny introduction over what sabbatical leave potentially are. And we're going to try to answer 2 questions, right? The first question is, did the absence of female professors affect the early career outcome of female graduates? And the second question is, what happens to the male PhD students who were in the same department as well? And to the first question, we're going to show you that there'll be a decline in the publication record of the female students that are affected by the absence of the senior female professor of roughly 33%. And there'll be a decline in the probability of placing in academia as well for the affected cohort of female students, and I'll give you more cue later on as to what I mean with that. And when we turn to the male student, we're actually going to find a mirroring opposite effect. The affected cohort of male students is going to have an increase in their publication record and is going to have an increase in their academic placement, to the extent that when we look at the level of the department where that female professor is missing, we're not going to find any effect whatsoever, suggesting that the male gains are going to offset the female losses. So that's just to give you a preview of what we're doing, but I'm going to work with you the different, component of this project and how we ended up coming up with this answer. So In order to study this question, we're going to focus on the top 50 US department. And the definition of top 50 we found is the one that's given by REPEC top 50 departments, and we're going to use the 2013-2015 years as our benchmark top 50 years. This is due to the sample we're using. That's the year that made the most sense. Now, why are we only looking at the top 50? Mostly because most of the PhD are indeed in those schools in the US. And I'm only going to think about and work on the US market from now on. And we can also see that in our sample, right? When we take the top 10 schools, they have an average of 20 PhD students. And when we go to the bottom 10 schools, there's an average of 7 PhD students, right? So not only that's where you see the highest production of academics, more PhD students in terms of number, but that's also where we're going to see the highest conversion rate to an academic position as well. And we wanted to study an environment where we could indeed see that production of professors. Now, what are we going to do with this department? We're going to collect 3 types of information. The first data we want to collect is the full faculty roster of this department through the time period of our study, right? Why do we want to collect everyone? Because obviously we want not only to get a sense of people who are advising PhD students, but we want to get a sense of everyone in that department who could have plausibly also advised, independently of whether they're advising someone or not. We're going to collect information for each of these schools about their PhD graduates, so we'll know the name of everyone who graduated from this school over a range of period, and I'll tell you exactly the time period. And then finally, we're going to look at the advisor-advisee relationship, meaning who is going to be advising which PhD students. And then for each of our PhD students here, we're going to look at their early career outcome, meaning we're going to take them right after they graduated, follow them 5 years after they graduated, and then look at their publication records during that time period, right? The reason we want to do that is because we want to have a measure that will be comparable independently of some of them, having a longer career versus a shorter career, right? Here, we're going to systematically try to find everything we can about these individuals for 5 years after their graduation, and then we'll get information on their publication records, on their citation, on their co-authorship, as well as on their placement, including the ranking of their placement, and I'll tell you more about these later. Okay. Yeah?
What is the average age of those PhD students? Do you have any information? Is it different between male and female?
So I do not know. So you asked me about the average age of the PhD students, right?
It's 5 years after the PhD, might be also a period in life where you may be interested in choices, research choices.
Yeah. Yeah. So I don't know the average age of the PhD students, simply because it's not an information we could easily get, right? Now, the way you want to think about this is that, independently of what happens in regular times, what we are going to do is exploit the variation from the sabbaticals, and there is no reason to believe that the women who are exposed by a female professor on sabbatical will be older or younger during this first 5-year period, and hence it's not going to drive or confound our results, the age of these women, and we'll only compare women to women. What, on the other hand, we're going to could be is that maybe part of the effect we're finding finding is precisely because women are at a certain age where maybe they're thinking about having their first kids, and some of these things might plausibly also matter and be mediated by the presence of a female professor during the PhD year. Okay, good. So we're going to collect information on all the faculty members and their positions. The time period we're looking at is between 1994 and 2019. That's where we had publication information. Where do we get this information? A mixture of university course catalog and department website. And to get the department website, we use what is known as a Wayback Machine, right? It's a giant internet archive that kept a snapshot of a website at different moment in time, going back, at least for us, like what we could find useful was things that went back to 2000, early 2000, right? We basically could find an old copy of a Harvard Econ Department website, for instance, in 2005, and then use that to collect everyone who worked at Harvard Economics Department at that time. And then once we have identified all faculty members and their positions, we proceeded in collecting information on when they took their leave, their sabbatical leave, right? So for those not familiar with sabbatical leaves, it happens that in academia, when you're a professor, you often, depending on the institution, you have the right to take 1 year of your usual academic duty in your home department, right? Typically what happens is that, in some places, every 6 years or so, the professor can go on sabbatical and visit, for instance, another department in another city or in another country, or spend time writing a book or doing something completely different from their teaching duties or administrative duties in their home institution, right? So what we are going to do is to try to identify in this data set all the instances where the faculty members in our data ended up going on sabbatical leave, right? To do this, we used the university course catalogs, which gave us information whenever someone was on sabbatical leave, the department website whenever we could find one that gave us the same information as well. But it happens that the information in these two sources were not systematic. So what we ended up doing was finding the CV, the curriculum vitae of everyone in our sample, and recorded every instance of these professors going on sabbatical. And this is what it's going to look like in our sample, right? We're going to have all these different departments, and the departments are going to have, for instance, here Berkeley has in 2004 one female professor on sabbatical leave, in 2005 another female professor on sabbatical leave, in 2006 the same thing, and then 2007 there is no one again, right? That is the type of variation we are going to use in our data set to try to answer the question we're interested in. One thing that seems to be important to keep in mind is the fact that most departments will have a woman full professor on sabbatical at a moment or another. You might not be able to see it very well from here, right? But you can see there is like up and down in most of these small pictures, right? And each of them is a different department, and hence whatever result we're finding is not only going to come from one department and will be generalizable across all the places that we have in our sample. Good. Now, next to this information on faculty members, we ended up collecting information about all the PhD students and their year of graduation across the time period we're interested in. We did that first by collecting, using the Journal of Economic Literature, all the dissertation, the doctoral dissertation in economics, and we also did that by collecting the metadata of all the theses. It happens that whenever we write a thesis, our thesis is cataloged in a library, and that library is going to keep record of our thesis, including often who is the advisor during our PhD, right? Not only the advisors, but the committee members as well, right? Now, all that is digitized, and it's kept in what is known as ProQuest Dissertation and Thesis Global, which gives us a very rich information about the production of academics, of PhDs, ultimately in a variety of fields, right? So we're going to use that alongside the JEL theses, and we're going to identify all the students who are going to graduate from one of these schools during that time period, and we're going to genderize these students. That really roughly means that we'll take the name of these students and then we'll apply a predictive algorithm that will give them one of two outcomes. Is your name a predicted female name, or is your name a predicted male name? That's really about what we'll be able to do here. Whatever remained there, what ended up having a bad prediction performance, we looked at manually, and we ended up really genderizing most of our sample. Okay, good. And then finally, we need to have information on the publication records. To get information on the publication records, we are going to use a very unique data set that we put together for a bunch of other projects. These are bibliometric data set. It's literally information about our work when it comes to publication records. It tells us the title of a publication, the authors of that publication, the year of that publication, and then the journal of publication, right? So these are the typical, bibliometric data set that information that we can find out there. What we did is try to construct the largest and most comprehensive data set on the production of economics that existed out there, putting, through many different sources information on citation as well, in order to be able to not only cover the top journals, but really cover every possible journal under the sun that was in economics or related to economics, starting from a set of journals that we identified being the journals that are either econ or econ related. With that data set put together, we created a unique identifier which helps us know all the publication that I had, because when we look at a data set like that, the first one, all we're going to end up having is a publication and some, and then a bunch of names, and another publication and a bunch of names, and another publication and a bunch of names. And the first thing we needed to do was to be able to put together all this publication that, I wrote under one specific identifier, and that's what we did there. Now, once we had that, we merged that data set with our PhD student record, right? Like this list we put together, and we merged them with the faculty member as well, and we ended up getting, thanks to that, information on publication, citation, and co-authorship. Next to that, for every PhD student in our sample, we ended up tracking their job placement. So now we know who ends up in academia and who ends up somewhere else. Okay, so These are the set of descriptive statistics on our sample, right? I'm not going to go too much into the details here, but what I want us to keep in mind is that within our sample, there 12% of our faculty members are going to be female, and 25% of our PhD are going to be female. 28% of our faculty members are going to be advisors, meaning we'll have a lot of faculty members that will just never advise anyone in our sample. And then a quarter of them are going to be female, and then the rest will be male. And finally, there'll be a variation across field. Not all PhD students end up in the same field, and it happens that labor and public is more of a female field. And that doesn't mean that it's more than 50% female. It's just that the female, within the pool of female, they tend, 30% of them tend to do labor and public. And within the pool of male, about 30% of them tend to do macroeconomics, right? And that will be the biggest divide we're going to see when it comes to PhD fields. Women do labor and publics, and men tend to gravitate towards macroeconomics. Okay, good. Okay, so now let's actually think about like how can we answer the question of what is the impact of the presence of a female professor on the early career outcome of the female PhD students. To answer this question, we're gonna face one super important challenge, right? And the important challenge we're facing is the selection problem. The fact that, female PhD students often end up selecting into different PhD programs based on a set of characteristics of the professors in this PhD program, the reputation of that PhD program, the specialization of that PhD program. Suppose that, I want to study macroeconomics, and I have the choice between a PhD program with a macroeconomist and one without. I might go in the PhD program with the macroeconomist, so I'll have like guidance in the field I'm interested in, right? And hence what will happen is that simply comparing how our PhD students in departments with more female professors do relative to PhD students in departments where fewer female professors do, we're going to confound all these other things, right? We won't be able to say that the reason we see a gap in their production is because there was one fewer female professor. What we'll end up having is that the gap might be due to any of these alternative confounder, right? So to answer this question, really we need to construct an appropriate counterfactual. And the construction of this appropriate counterfactual, the way you want to think about this is, what would have been the early career of a PhD student had there been one fewer female professor in the department they were at, right? Our best answer to solve this problem is indeed to use the sabbatical leave as a source of quasi-random variation in the presence of female professor. And really what we're going to do, we're going to estimate the effect on the early career of these students of the differential effect of female students who are in a department where one female professor went on leave compared to a female student that was in a department where that female professor didn't go on leave, right? And our effect will come from that variation, which we believe really has three advantages, right? The first one is the sabbatical leave, as I explained to you, is really some form of temporary absence of a professor from a department, right? That sabbatical leave will generate a small decline, right, like a temporary, a short decline in the professor engagement in that department, right? So that's the first advantage. We wanted to look at, the effect of having a female professor present, and here we have a variation that will de facto decrease the presence of a professor in a department, right? The second advantage is economics is a male-dominated profession. I don't know if you saw the results earlier, but there is a mean of 1.77, like, female professor per department. Obviously, if one of these female professors goes on leave, that might generate a substantial decline in the presence of female professors in this department, right? And then finally, because it's a temporary change and often students don't know when professors go on sabbatical leave, it is going to be not related to the potential outcomes. It's going to be orthogonal to the students' potential outcomes, right? And this is really mostly because the timing of the sabbaticals are really unexpected by the students, and hence that problem I told you earlier, a female student going to a department, maybe because there is this female professor they wanted to work with, right? That type of problem will not happen in our study because the variation in the presence of female professor will come from these sabbaticals, which we believe to be orthogonal to students' potential outcome, right? So now, what are we going to do? We're going to define a dummy variable equal to 1 if the professor is mentioned to go on leave in a course catalog or a department website, or the professor is listed as a visiting professor at another department in our sample, or whenever we find in the CV of the professor a leave or a visiting position, we're going to assume that that professor is on leave and create our variable like that. Okay? Good. So, as I was telling you earlier, because there are so few female professors in a department, whenever one of them goes on leave, is going to generate a rather meaningful decline in the presence of that female professor, right? We can see this systematically in our sample by running a regression model. Are you all familiar with what a regression model is? Yeah, we're good with econometrics, right? Otherwise, I can start there my talk, and then we can come back to this result. But what we did is that we run a regression of a dummy variable for whether a department D at time t had any female professor present on a set of indicator for whether the female professor went on leave, looking at up to 5 years before that professor went on leave to 5 years after that professor went on leave. We use department fixed effect that will capture the fact that maybe some departments have more female professor compared to others, and we'll use time fixed effect that might capture that maybe at some period there might be more female professor, maybe in the later part of our sample compared to the earlier part of our sample, right? Okay. And what do we find, right? What you're gonna see here is the coefficient, right? So if you go here, what I'm gonna do is that I'm gonna estimate these coefficients, right? One for each of these time period up to 5 years before the leave and 5 years after the leave, right? And we're gonna look at whether the department where that professor was has, any female professor present, or what happens to the share of this female professor present when the professor goes on leave, before the professor goes on leave, and after the professor goes on leave, right? Good. And what are we finding? We're finding that the probability that there is at least one professor in the department declined by 15 percentage points the year the professor goes on leave. There is no change before, meaning the years before the professor goes on leave, and there is no change the year after the professor goes on leave, right? So what does that mean? That really suggests that, the professor going on leave is really that short temporal decline in the presence of a professor. The same thing we can do where we use as a benchmark that a department with at least one professor had 100 professors present, and we can see that there is a decline of 41 percentage point in the share of female professor present in this department, right? And that's what we see here, right? Okay, so the big takeaway here is that, we ex ante thought that sabbatical was a good, source of variation to study, the presence of a female professor. And the first test we have to do is to actually check whether indeed our variation is working as intended. And we find that, yes, it generates a decline in the presence of female professor in the department, and that decline is temporary, exactly as we were expecting, right? Good. So now, one more thing we can do is, okay, we look at female professor on leave. We believe that this is going to generate meaningful change in the presence of female professor. But what about male professor? Do we find similar meaningful change when a male professor goes on leave? And, that's just some form of quick sanity check, right? Obviously, when a male professor goes on leave, which we can see with this color here, right? The decline in the presence of any male professor in that department, right, in the share of any male professor in the department is just substantially lower than what we find when a female professor goes on leave, right? So while we might expect an effect when a female professor goes on leave, if we were to play the same, game with male professor, right, if we were to ask the same question with male professor, we might not find much, at least not on the gender dimension, simply because there are just so much more male professors in this department, right? Okay, and one more thing that seems to be important is, you remember I told you that having a female professor on leave should not affect the selection of students in this department. That's something we can also check specifically in our setting. We look at the number of, the share of female students that graduate every year relative to the year the professor goes on leave. And we can see that really there is not much going on, right? So this female professor on leave doesn't affect the pool of female professor, neither before nor after, the pool of female students neither before nor after. On the other hand, what we're going to see is mostly this shock on the presence of female professor. Good. Okay, so now we're ready, once we have our variation, to look at the impact on the early career of these students, right? But one thing we had in mind when we started this project was that not all PhD years are going to be equally affected by the absence of female professor, right? And typically the way you want to think about this is, suppose a professor goes on leave in 2000. Now, there'll be a bunch of students in that department doing their PhD. Some of them will be in their first year when the professor is on leave. Some of them will be in their second year when their professor is on leave. Some of them will be in their third years when the professor is on leave. And some of them will be in their fifth year when the professor is on leave, right? And there's no reason to believe that the impact should be the same on each and every one of these students, right? In particular, the typical schedule of a PhD program is you take courses the first 2 years. The first year, indeed, you take, the general core courses. The second year, you take the course of specialization. And then usually, you start your research development stage where you work on your own thesis on the third year. You develop that thesis a bit more on your fourth year, and then you get ready to go on the job market by the fifth year, right? In particular, our hypothesis when we started the project is the female professor on leave although could have different impact on these different years, will have a particularly strong impact on the students who are starting their research career, who are starting to figure out what to do for their research, knocking on their professor's door, trying to find their advisor, trying to develop their ideas as well, right? But what we're going to do is we're going to leverage this timing, and we're going to be relatively agnostic beforehand and interact the female professor on leave with each year of that sabbatical, each year of the PhD, in order to let the data speak for us, right? The problem we faced when we started thinking about this heterogeneity is that we didn't know the start year of the PhD. We only knew the graduation year of the PhD in our data set. So what we ended up doing in this study is to take every one graduation year and subtract 5 years from that. And the reason we subtract 5 years from that is that within our sample, it happens that 5 years is the norm in terms of the number of PhD years to completion, right? And I can show you statistic there. We do some form of robustness playing with these average number of years, and our results remain robust to that as well, right? Okay, so now what does that mean, right? The way we want to think about this is, take Claudia Goldin. Claudia Goldin is a female economist at Harvard University, and she, in her data set, went on sabbatical in 1997. Think of it as the academic year 1997, meaning September 1997 to May 1998, right? Now, the first year student will be the student who started their PhD in the academic year 1997, the year she went on sabbatical, and graduated in 2001, meaning the sabbatical year plus 4 years, right? We're going to identify the second year students as the student who started their PhD in 1996, meaning the sabbatical year minus 1, and graduated in 2000. And the third year student will be the one who started in 1995 and graduated in 2001, right? So we want to keep in mind these things, because I'm going to show you a bunch of pictures, and I want you to think about this, the 0, as the students who graduated the year the professor went on sabbatical. The 1 to be the student who graduated 1 year after. The 2, the student who graduated 2 years after, and hence we're going to identify the third year PhD student with that number 2 here, right? Okay, so I'll come back to this in 1 second, but what are we going to do? Our main empirical strategy here is to run a regression of the female PhD student outcome, early career outcomes, up to 5 years post-PhD, on a set of dummies here, on a set of dummies that capture whether that female student I in department D had a female professor on leave S period before versus after they graduated, okay? And we want to look at 3 outcome variables: whether the student has published any paper during this 5-year period, whether the number of papers that the student published, and whether the student ended up in academia, right? Again, this variable here is a dummy equal to 1. If the student is exposed to a female professor on leave, S years before or after the graduation year T, we believe that all the cohorts that are plausibly affected by the female professor on leave will be the cohort that have an S equal to 0 to an S equal to 4, right? Good. We're going to have for everything department and year fixed effect, and everything will be clustered at the department level. Okay, good. So the first result is we really don't find anything except for these students here, right? The third-year PhD student seem to have a decline in their probability of publishing any papers in their early career. Now, if we look instead at the number of publications, we find a decline in the number of publications as well. Again, only for these third-year PhD students. To the extent that when we look at the coefficient on that female sabbatical for the third-year PhD student here, so T-2 capture the third-year PhD student, we find a 15% decline in the probability of publishing any paper and a 33% decline in the number of publications relative to the baseline mean values here. Okay? And finally, if we look, instead of looking at the probability of publishing, we look at whether the student has a placement in academia, we do see a decline in the probability that the third-year PhD student end up in academia, right? So now I want to go back to these early sets of pictures I showed you, right? The one of this gender gap in representation, right? We see fewer women in academia, right? It seems that this first result suggests that a senior female professor missing is going to lead to fewer female professor, assistant professor in academia and contribute to that gender gap, yeah?
When we measure the impact of sabbatical leaves on student place in academia, is the number of papers published controlled?
So the number of papers published of the student is the outcome variable we're going to look at. The placement, right, this one here, is really the placement right after the PhD, and it happens that, you know, few students publish before, you know, they finish their PhD, right? Something else that's important is that we would not be able to control for the number of papers after the PhD, simply because it's an endogenous variable itself and it could mess up our coefficient, right? But that's a very good question, right? You know, in this setting, it happens that among economists, students do not often actually publish papers after, you know, before they get their PhD, at least not in our sample. Okay. Good. So, the third result is that we see a decline in the probability of placing in academia. Now notice that the effect in size are very similar when we look at the probability of publishing and the probability of staying in academia, right? Like these two numbers, although come from different data sets, are talking to each other. They seem to be telling us like a similar story. Okay. Now we want to turn to the male student, right? So what are we going to do here? In this color here, we're going to see the female student. That's what I've showed you before. And then we're going to have the male student in this orange color overlaid on top of the female student. What did we do? We just rerun the entire regression. Instead of looking at the female student outcomes, we just rerun it only looking at the sample of male student. Yeah.
So how much of this comes from like direct supervisees of the female professors and how much from like...
Yeah, so this is super important, right? Like what we can measure is a female professor during your PhD being absent or present, right? Now part of the effect we believe comes from finding an advisor, right? And the fact that you might not actually have a female advisor and that could plausibly hurt you going forward doesn't have to be only that, and hence you're right, we would be interesting to think about how much of that effect is directly through the matching versus something else going on as well, right? And I'll come back to some of this later. Okay, so now the big and surprising result for us when we did this project was the result for the male student, right? And what's really interesting here is take the probability of publication there is a decline in the probability of publication, right? They also drop out of academia, right? So here we're thinking about one fewer female professor and then the impact on the next generation of academics, right? And but then what's interesting is that the male have some weird like mirroring effect for that cohort, right? The male students are more likely to publish and they're more likely to end up in academia and they publish more papers, right? And that, at least like when we started the project, was probably the most surprising part of our result, right? Why should it be that suddenly the male student end up benefiting from it, right? And I'll try to tell you some answer to that. What is true is that, you know, it's a variation. We looked at it in a pretty agnostic way, and the data set ended up speaking in a pretty striking way. And there is really not much we could do, right, think of maybe it's the way we build our sample, maybe there is something, the way we measure things, etc. These results seem really to be strongly present, where the female student lose, the male student seems to be gaining, to the extent that I'll show you later, we put everything together at the level of the department and there is a zero effect, right? Meaning, from the point of view of the department, they have as many students in academia, they publish as many papers, and their probability of publishing is exactly the same, right? Okay. Now, notice one thing here, right? Your male student here, the size effect is slightly smaller, right? The opposite sign. There are also fewer female students in a department compared to the male student, right? So when we aggregate everything, we have to weigh it by the share of male to female student. So, you know, at the individual level, it could be that there's just a smaller loss for the male student, right? Okay, good. And then as I was telling you, we put everything together, male and female together, and really we can't detect statistically any effect, right? And that for us was also a surprising result. Okay, good. We've done a bunch of robustness, right? I'm not going to go over too much the details of this robustness, but we checked, as many things as you want, and this is something typical when you do empirical work, right? You have your empirical strategy. You want to show that the variation you're picking up is indeed picking up what you think it should be picking up, right? But then afterwards, we have to show that there aren't anything in our result that might be driven by maybe some definition that we use that we could have used another definition. Maybe there is something about some other confounder that we could be using, right? For instance, one important thing we ended up doing was using a stronger regression where we control for a department and a 5-year sets of dummies, right? In case through time there were more women professor, we didn't want our result to be just driven by some weird underlying trend in things, and it happened that it's not. We've also dropped one department at a time in our sample to see whether our results were driven by maybe Harvard only, or maybe Princeton only, or maybe MIT only. And our results are pretty robust across all these things, right? Okay, good. The next question we need to ask, right, is, okay, there is a decline in the probability of staying in academia. There is a decline in their publication record, right? But we might just want to know, is there a decline in quality as well, right? Does that follow with it? Or when we look at quality, there's not much going on with quality, right? We use 3 usual measures of quality that's used in the literature. The first one is the number of top 5 publications, right? So just to give you a sense of how economic publication works, economic publication is about publishing in a bunch of journals. It happens that some of these journals are higher quality journals in terms of their requirement over what would be called a contribution, or how difficult it would be to publish in those specific journals, right? There are 5 of them that the profession, I think that you would agree with me, there are 5 of them that the profession kind of agreed were the top 5 publication, and we're going to use that as one measure of quality. What's your probability of publishing in one of these top 5 journals as a first metric? The second one is to look at citation, right? How many citations per publication per year, do we see in terms of the papers that these guys have been publishing, right? And then finally, we want to look at placement ranking. Again, the idea is not all departments, not all universities are alike, and some universities have more prominent professors, have professors that write higher citation papers, right? And there are rankings out there that we can use. We use this ranking and looked at whether women, whenever they're missing from academia, are they missing in the better schools versus the worse school? Okay, good. Again, all these measures are measures that we could use, that are observable. None of them are fundamentally perfect measures of quality, obviously, right? And I think that there are discussions out there over finding better measure of academic quality. Okay. So, let's look at our results. From now on, I'll show you just the coefficient for the third-year PhD student, just to make things slightly easier as I'm going to scroll through a bunch of results, right? So, I'm showing you at the top panel here the total number of publications, right? In the panel B, we have the number of top 5 publications. And then here, I'm going to show you the average citations. Okay? Good. So what do we find? We find a decline in the total number of publications of women. These are our baseline results. Yeah? We find a pretty substantial decline in the number of top 5 publication, right? And indeed, you can see, right, there is a 60% decline in the number of top 5 publications by these female PhD students who happen to have one female professor missing, right? So that for us was pretty striking again, right? We weren't expecting to find so large result. And now when we look at the male students, these are our old results, there is an increase. Really, in terms of quality, we can't quite distinguish it from a 0 statistically. And the same thing here for citation, we really can't find much result for citation, but at least in terms of top 5 publication, women seem to be publishing in worse, less in these top quality or top journals, right? Okay, again, just for the sake of it, okay. Just for the sake of it, so does that happen automatically every day at this time? It's good. Yeah. In some countries, they start, at the radio, the national anthem, and then, at ONS, they just bring everything down nicely. So here, we have, the usual no result at the department level that we see all true, right? Okay. So now, in terms of quality, at least for women, there is a substantial decline in the number of top 5 publication in their early career outcome. Okay. Now, We could, instead of looking at all the students, look at the selected students in academia, right? And ask ourselves, is how much of this decline is really because they just don't publish anything, right? And we still find actually a substantial decline. It's not statistically significant at the 5%, it is at the 10%, right? So we cannot distinguish it with a zero, at least at all conventional level. And again, for the men, we just don't find much when it comes to the quality channel, right? Okay, good. Now, one question, right, is we see them publishing fewer papers in top 5 journals. Which part of that decline is precisely because they are not placing in better schools, right? It could be harder. You might have fewer means if you end up at a school that has less grant money available, for instance, right? Or where your colleagues, you might have fewer of them, maybe fewer of them are actually doing research, right? There might be a bunch of things that could affect your publication. But to start with, the first question we want to ask is, are we going to find results in terms of their placement that mirrors the result in terms of the top 5 publication? And indeed, right, if we run a multinomial regression model, here what we ended up using as the excluded category, the base category, is being out of academia. So you'll notice that these probabilities, these are the marginal effect that we're showing, are going to sum, if you sum these two, you're going to end up having the coefficient here. This is really mechanical, right? And what do we end up having? We have a decline in the probability of placing in a top 25 econ department. There is also a decline in other departments, but it can't be distinguished with a zero, right? And then finally, this is going to contribute to the decline in the probability of placing in academia for the women, to the extent that actually a huge chunk of that decline is only explained by the women missing at top school, right? Okay? Now, for the male, what we're going to see is that, there is indeed, a change in their probability of staying out of academia. They're more likely to stay in academia, but most of it comes from the other school, right? So there is indeed not a comparable replacement, right? From the point of view of the department that has that female professor missing, they are going to have the same number of people in academia, but their PhD students are indeed going to be missing at top schools, right? And that's one important result that we can take from this, meaning it is indeed not equal. It might be equal in numbers, it might be equal in terms of placement, but it's not equal in terms of representation when we think of quality of department, right? And hence, once we look at this, right, that seems to kind of be mirroring the result in the top 5 publication. And hence, one simple question we might have is, how much of the decline we see here for the women is driven precisely because the women do not place in the better departments and hence have fewer means and fewer resources, and their colleagues are different, etc., right? Maybe their incentives are also different. In top ranked schools, they have to publish top 5 in top 5 journals to get tenure. In lower ranked school, you might not have the same requirement, right? So you could plausibly think that the result might actually come from that placement. So what did we do? We ended up running the regression we run above, but instead of running it on their actual publication, we run it on the average publication of their placement location, right? And what we find is that we can indeed explain part of the decline from their placement, right? So the difference between this number and this number is that this is their own publication, and this is their publication according to the average of their placement, right? And you can see, right, like, it can partly explain the decline that we're explaining, that we're having in terms of publication. It doesn't explain everything, meaning there is something else left out. And really the main takeaway here is, these formative years, these PhD formative years, right, are indeed very important. There seems to be a gender channel at that stage, right? Like somehow having a senior female presence does something. Now, whether it decreased the human capital formation of the PhD or whether it hurt them because their network or the senior professor or the mentorship is not there, right, or they're not pushed as much when they go on the job market, is something we could not quite disentangle. Yeah?
One question that also aligns with your previous explanation of that people need to find their advisors in the third year would also be that, like, the missing top 5 applications are situations in which these students are the junior co-authors of the PhD supervisors, and maybe like the gap comes solely from not being part of the supervisors' publications.
Yeah, we could look at that directly. So we could look at the extent to which it affects their own probability of publishing, and once we take that paper out, do we still find an effect or not, right? Down the line, and that actually seems to be a very fair and decent, explanation for what we might plausibly find, right? Good. Okay, so missing female professors impact the early career outcomes of PhD students. There is a decline in female publication and academic placement. There is an increase in the female, in the male publication. So here we have a typo, it should be male. And really what we find is the female loss, for the most part, seem to offset the male gains with one caveat, and the caveat is the one on institution representation. Yes? No questions? Good. Women are missing at top-ranked schools. The male enter the academic system through lower-ranked schools. The home institution end up having something missing, right? Good. So now we might wonder, right, what do we do with these results, right? What do they fundamentally imply when it comes to, DEI, diversity, equity, and inclusion, and policies to increase, more women, in the population? One thing we did, right, is to play some form of small hypothetical exercise, right? So assume that our estimate really capture the presence of a female professor, one female professor, right? And think about the following scenario. Assume we hire one additional professor, senior level professor, in each department in our sample, right? Obviously, this is going to naturally increase the gender representation at the senior level, right? We'll get just more women just out of that policy, right? But the question we want to ask is how much of the gender gap among the assistant professor does our coefficient manage to close, right? So what we did was hire one additional senior level female professor, holding everything else constant. What we end up having is a certain number of female students in our sample, right? We multiply that number by the probabilities of placing in this top 25 school. What does that mean is that we multiplied it by the 3.9% here. Yep. And then what we end up having is this top 25 school, right, which now gain a female professor, had before 21.5% female assistant professor. And just having this senior level female hire would change their share of female assistant professor from 21% to 32%, meaning there'll be a 50% increase in that assistant professor gender representation out of this policy, right? So this policy will give you more women at the senior level, but will give you for free more women at the assistant professor level as a side effect, right? And what's interesting about this policy and our result is that usually when we think about diversity hiring, right, like there is one big discussion that everyone seems to always think about, and that discussion is over quality and meritocracy, right? If we, help a woman and hire her or give her preferential hiring, then we are hurting, the quality of our pool of professors, right? That might not go in the direction of a meritocratic hire, right? And somehow our results seem to suggest, right, that there is really not much, trade-off in terms of quality, and indeed, we'll end up having more female professors and really minimal loss in terms of publication and quality, kind of giving an argument against all the pushback against female hire that often goes in the direction of if you hire more women, you're really hurting quality. In this case, it doesn't seem that there is much result when it comes to actually the productivity at the level of the school, right? It's kind of a replacement that we see, and hence our result are really a result of equity more than one that seem to have much efficiency type implication, right? Good. And then from the point of view of these top 25 schools, which have a particularly low female representation, right? The assistant professor gender ratio in the top 25 school is actually pretty low. What we end up, getting is, just a free, gain for them, right? Obviously, the world is not simple. There's tons of stuff going on in the background, right? And you'll have to believe that this hire, extra female hire will leave everything else constant, and we do understand that many other stuff could plausibly be affected. Good. Great. So now, last but not least, right? Let's talk about this shift of opportunity, right? We saw the female students have a decline in their probability. The male students seem to be gaining, right? Now, what do you think explains this shift of opportunity? How do you think, if you had to come up with some, reasons behind, why is it that a female professor missing suddenly end up helping the male PhD students, right? There is no real reason ex ante we should think that happens, right? So do you have any thoughts as to what could explain this mirroring effect? Yeah?
As you said, the matching between female supervisors and female supervisee, it's not really the effect of a woman leaving the department, but rather the effect of the supervisor leaving the supervisee.
Okay, so you're thinking that it's because the supervisor, so here you're thinking about the female supervisor, now is not supervising the male student. Is that what you have in mind?
I think there is a higher proportion of female PhDs supervised by female supervisors rather than male PhDs supervised by female supervisors.
Okay. So you think that the effect could be that the sabbatical led more female PhD students to be advised by the female PhD student, professor, and then the male PhD students are advised by someone else. Those are the ones who end up moving away.
Let's say if there is a higher matching between female supervisor and female supervisor rather than male supervisor and female supervisor. The leave of a woman professor will end up leaving female PhDs more alone
Yeah.
as supervisors than
Yeah.
the male supervisors.
Okay, yeah, so that could plausibly be, but why should it affect the role, like the male PhD students, ultimately, if their life hasn't changed, right? You know, why should they be better or worse at the end of their PhD, right? Like if they have the same advisors than they used to have, and they have the same life than they used to have, you know, why should they also be affected, right? I think your answer is in the right track, right? And that's also like, you know, the way we're thinking, but you kind of almost need like an extra, you know, economic explanation for that mirroring effect, right? Anyone has any other thoughts on why is it that the male student end up gaining from the female professor absent?
I mean, maybe something like seminar cultures, that some kind of more super aggressive something culture benefits some kind of econ male nerd more.
Sure, yeah.
Women.
Yeah, that indeed the environment is different because that female professor wasn't there, right? But then you have to believe that this happens 1 year and that affected the third year PhD student and not the other student, right? Which also might be a bit, you know, more difficult to explain. To be honest with you, the best explanation I could give to it, right, is related to what you're saying, but you need to explain the effect on the men as well, is that, you know, when we go for a job, right, often there is one position and we're ranked against each other, right? So you don't need to see the male student do better or worse. All you need is that the female student go down the ranking for the male student to mechanically benefit, right? And you know, in an academic environment where we all build relationship with our advisors, right? Imagine that for some reason the female professor is missing, and now there is a bunch of female students, not all of them, but there's a bunch of them that have harder times finding their ideas, finding an advisor, finding the right advisor. They end up with someone, but it never glues, it never works, right? Now, at the moment of going on the job market, all the students are going to be evaluated, right? Where should we push them? Where should they be sent? Which job can they apply to, right? Maybe you don't need to see the male student, you know, become better or benefit in terms of human capital. All you need is the female student to not be pushed, for the male student to mechanically, like, you know, benefit from it in an environment that's somehow competitive, where, you know, you'll have to put everyone somewhere somehow, right? That's the best answer I could provide to it. Like, it's almost like an unintended consequence of the female student not being pushed, is that, you know, a bunch of male students who enter from the lower ranked school end up, like, you know, being, like, you know, bumped up, right? Okay, so we don't have much evidence for that, but that's one plausible explanation, is that it's the unintended consequence of the negative effect on women in a competitive job market, right? Now, where does that unintended effect come from? We believe that it's because of the importance of this relationship for career outcome. Yeah?
Why would it only be the case for third years PhD students?
Yeah, I really think that we'll come back here on it, right? It happens that we really fundamentally find our advisors and settle into a research during that year, right? So the first 2 years, you take courses, right? You take your general course, and then you take, like, you know, a bunch of, like, you know, options, right? During this option, you might connect to professors, this and that, and I thought I was gonna find something there as well, right? But really, the year you start thinking about who is going to be my advisor. I'm going to settle that, in some more formal way. I'm going to go and knock on the door of that professor and start thinking about my project, right? That happens in the third year of a PhD. And then, some students still keep on developing things in the fourth year of their PhD, right? So now, my thought, at least from my own experience doing a PhD, right, is suppose that during that year, I knock on people's door, I try to talk to professors, and somehow, they just sit in front of me and it doesn't glue, and I provide them ideas or whatever, and they never engage with anything, and they talk to me, and maybe they talk to me in a colder way or whatever it is, right? Then maybe I'm, not gonna, be too engaged in that process, right? The flow of information between us might not work as much, right? I might think that I don't really like working on my thesis, I don't really engage with it, right? And that kind of crystallizes in that third year. It could be that the fourth-year PhD students have already built that relationship, and hence they don't suffer as much from it. The fifth-year PhD students have already built that relationship, and hence they don't suffer as much from it, right? So that's our best answer, for it. And indeed, right, we're going to try to find you some evidence of that gender nature of this relationship, right? So we hypothesize that a result can be explained by two factors, right? The first one is the importance of professional relationship, and the second one is the gender nature of professional relationship. And then what I'm going to do for that last chunk of the paper is to show you that there is gender homophily in advisor-advisee relationship, that these sabbaticals create a break in relationship, right? That indeed a professor who is on sabbatical will have fewer PhD students, precisely those who were in their third year of their PhD. Then we're going to show you that the affected third-year female PhD students are less likely to be matched to a female professor, and they're going to be most likely to be matched to what we're going to call a busy professor, meaning a professor that will have a lot of other PhD students, in particular other female PhD students, right? And hence, we can provide some evidence of relationship being weaker, among others looking at co-authorship. But right now, we're trying actually to look at the thesis of the students and play with the thank you note in the acknowledgement to try to measure in a way or another, some form of connections that the students could plausibly have with their professors, right? Okay, so the first picture is that female students are more likely to have female advisor. What we're seeing here is what would be the share of students with a female advisors if the matching was random, right? That's what we find here, right? If we were literally just to pick a female professor and a female student and match them randomly, what would we get, right? Then we can see the share for the female student, which is very similar to the random share. And then we can see the share for the male student. Going back to the point you were making, the male student, indeed, it seems that those are the ones who are not working with the female student more than the female student working with the female professors, right? So the male students tend to not work with female professors. Okay, good. Now, we can run a regression on the probability that a female student has a female advisor, controlling for a bunch of things, and we control for more and more stuff up to this regression where we're controlling for an interaction of year, department, field, fixed effect. And we find really results that are somehow very similar. Female students are more likely to have female advisors compared to the male students relative to a baseline of, it's going to be roughly around 10%. Okay, good. Now, the next picture is that a female professor on sabbatical have fewer students. Actually, any professors on sabbatical seem to have fewer students who are in their third year of the PhD or their fourth year of the PhD. So that's the other one we can find. And then finally, we can look at the characteristics of the advisors they end up matching with. And it happens that the female PhD students with a female professor on sabbatical are less likely to have a female advisor. But they're also more likely to work with an advisor that has a lot of other students, right? So maybe part of the result is really a human capital result. They end up with professors that actually seems to be very busy. And we, again, do not find much for the male students, right? Again, suggesting that maybe the best explanation for it is indeed this unintended consequence, either living in a profession where we're somehow ranked against each other, right? Okay, so strength of relationship, these are really like preliminary results. We have to do a better job in terms of like, providing evidence for that. This is very noisy, but we start like, finding some evidence of lower likelihood of co-authoring with your advisor and a lower likelihood of being placed in an institution that's connected to your advisor, but this kind of goes a bit all over the place, right? Okay. We try to discard other explanation for it, right? Is it because female PhD students like certain field and the female professors now are missing from this field? Is it a field effect? We can show that this is not driven by the field. We can also show that this is not because when female professor goes on leave, male professor tend to stay. And hence, the effect we find on the male student is just because there is a presence of a male professor. And that kind of concludes the entire thing, right? We look at the effect of female professors on the early career of female PhD students. And it does seem that we have a result on equity, we have a result on representation, right? And there isn't really much going on when it comes to thinking about, efficiency, right? Like it's really a transfer from one group to another group, right? We're gonna use the same variation to look at a bunch of other things. Among others, we've been working on looking at star professors. Do star professors produce star, economists, right? And there are other things we can do, among others. There might be other dimensions of identity that are important when it comes to our profession and to the production of human capital in our profession. Ultimately, when we think of this PhD student, what we think is that a professor is, producing another professor, right? That's one way we can think about the process, right? And the main question is, how are other dimensions of identities, right? Other dimensions of cultural identity is actually important when it comes to thinking about that production of professors by professors, right? To do this, I've given you some form of hint, right, at the type of data set that we're using. These are incredibly rich and detailed data set, and I kind of want to have a mini spiel about, the data set before I end this talk, right? For anyone who is interested in doing research on this type of questions, right? And the mini spiel I want to have about this data set is, it's really hard to find a data set where you can measure individual level productivity, right? And it's really hard to find a data set where you can find that alongside your connection to your colleagues, right? Where you can actually observe it. For instance, take any company out there. Companies work in team that have colleagues and managers. The most we might be able maybe to measure is how much is the team producing, right? It happens that our world, the academic world, is one of these rare environments where we can observe how much people are producing. Yeah? We can observe that alongside the people they work with, they engage with, they talk to, the department they work at. And hence, it really opens up, beyond studying academia. It really opens up like a lot of questions we can study empirically that are at the interaction of productivity and network, productivity and inequality, productivity and identity, that we might not have been able to answer with that type of data set. I kind of wanted, like, you know, to, you know, kind of like provide some, like, you know, a selling point to this environment that I'm studying that can help us understand beyond the environment phenomenon related to inequality more generally. Thanks a lot for, I don't know, how long did I talk? An hour?
An hour 50.
50? Oh, man.
40.
Hey, thanks a lot, right? That's a lot to listen to someone.
Do room for questions?
So how many female professors do you have? One? Is that right?
50%.
Yeah? Like you basically are inner statistic, right? Like thanks to you, the department has 20% female professor. Is that right?
50%.
Is that right? 50?
And we lose 100% of our female faculty.
Exactly. That's amazing. Small number generates discontinuity, right? And good.
Have you studied solutions or the efficiency of solutions?
Well, what do you mean? Solutions for this? Like what we could plausibly do in order like to have more human? I really think that, at least from what I am learning from the process, right, that, you know, you can't replace, you know, organic relationship, right? And, you know, we can't also make them up, right? I can't suddenly, you know, force someone to like someone else, right? And, you know, somehow where I'm like, you know, going is that there is a case for having representation of different groups at decision-making positions, right? That if you really want to actually, like, you know, help entry and decrease barrier, one simple powerful channel might just be having more representation of different groups on at decision-making part, right? So hire more senior female professors might be actually a very reasonable way of approaching this, right? And then maybe having workshop where male and female end up like getting along with each other more. I don't know, right? Like, you know, I think all that becomes a bit fictitious, right? But it does seem that we could explain a lot simply by hiring more female at senior level. Yeah. Good. Yeah, feel free to reach out outside as well. I think that my email is shared, or yeah, is it? Yeah.
Send you an email with the email of Sahar.
If you want to ask me more questions about that, more than happy to answer. If you're interested in that type of research, I'm more than happy to guide you as well there. Good. Thanks a lot.